Hello, welcome back. In this video, we'll discuss the energy materials and we'll focus on the electrolytes. The energy materials are a class of material with high amount of stored chemical energy that can be released, meaning these materials can store energy in the form of chemical energy, and as and when required, depending on the design, one can make the material to release the energy as per the requirements. Energy materials or energetic materials are a class of materials with high amount of stored chemical energy that can be released. The energy materials are a class of materials with high amount of stored chemical energy. The energy is stored in the form of chemical energy in a energy material, and this energy can be released. The examples for the energy materials are explosives, propellants, fuels, electrolytes. Our discussion will be mainly focused on the electrolytes. The electrolytes are a special form of energy materials that can store energy in the chemical energy format, and as and when required, they can release the electrical energy. The energy storage devices, they require suitable ionic conductors. The electrolytes can store the energy, and the devices developed using the electrolytes to store the energy are known as storage devices. The storage devices, they deal with spontaneous spatially separated redox processes, and they require suitable ionic conductors. The storage devices, in this case, storage devices means the energy storage devices like batteries, suitable ionic conductors. Since we are using ionic conductors, the performance of the energy storage device depends on the properties of the electrode surface. Performance of the energy storage device depends on the electrode surface and the electrolyte. There are two categories of electrolytes largely that are used in energy storage devices, namely the liquid electrolytes and the solid electrolytes. Now we shall see what an electrolyte is. Electrolytes are usually liquids or solids which conduct electricity through the movement of ions. Ionic conductivity is mutually connected with ion transport under the influence of an external electric field. So the definition of electrolyte goes this way. Electrolytes are usually liquids or solids which conduct electricity through the movement of ions. The movement of ions gives rise to ionic conductivity, and the ionic conductivity is mutually connected with ion transport under the influence of external electric field. So here there are two components to this. The first part is electrolytes are usually liquids or solids which conduct electricity through the movement of ions. Whenever we have the movement of ions, we have the ionic conductivity. Ionic conductivity is mutually connected with ion transport. Ion transport is the mechanism that explains the ionic conductivity in solids and liquids, and the ion transport takes place under the influence of external electric field. There are several properties which are fundamentally different in the case of electronic and ionic conductors. The ionic conductors are largely divided into three categories. The first category is inorganic solid electrolytes. The second one is liquid electrolytes, and the third one is polymer electrolytes. The mechanism of conductivity and the area of applications of these materials are drastically different. Now we shall discuss the ion transport mechanisms. There are three characteristic modes of ion transportation. Modes of ion transport in ionic conductors. And these three are, the first one is migration. In this mode, charged species move to equalize gradients of the potential in electrolytes. Charged species move to equalize gradients of the potential in electrolytes. So the first mechanism is migration, in which the charged species, they move to equalize gradients of the potential in electrolytes. So there are certain potential gradients in the electrolytes, and these charged species, that could be anions, cations, they move to even out the gradients. The second transport mechanism is convection. The material is forced to move by an external force such that electrodes, they rotate. This mode is typically applicable in the case of liquid electrolytes. In convection, the material is forced to move by an external force such as the electrode's rotation. The electrolyte should be a liquid electrolyte. The third type is the diffusion. Diffusion occurs when a species movement occurs under the influence of a gradient of chemical potential. So diffusion is a species movement occurs under the influence of a gradient of chemical potential. The chemical gradient potential, they occur because there exist certain concentration gradients. These chemical gradient potentials are due to concentration gradients. The solid electrolytes would be more desirable in large scale applications. In large scale applications, the solid electrolytes are used. The solid electrolytes, they address the issues like corrosion. In the case of solid electrolytes, corrosion problems can be minimized. In liquid ion conductors, it is possible to change the electrolyte concentration easily. Because it's a liquid, one can add electrolyte to maintain the concentration of the electrolyte. Thereby, one can control the ionic conductivity at a given temperature, because the ionic conductivity depends on the concentration of the electrolyte. The electrolyte can be added to maintain the desired concentration. The solid electrolytes can be single crystalline, amorphous, and polycrystalline. There is a peculiarity about the solid electrolytes, that is, in general, liquid electrolytes have negligible electronic conductivity. At the same time, numerous solids show noticeable electronic conductivity even at room temperature. Peculiarity of solid electrolytes is electronic conductivity can be seen even at RT, room temperature. Whereas in the case of liquid electrolytes, the electronic conductivity is negligibly small. We have started our discussion by defining what energetic materials are. We have said energy materials are a class of materials with high amount of stored chemical energy that can be released. The examples are explosives, propellants, fuels, and electrolytes. Electrolytes are generally used in storage devices, and they require suitable ionic conductors. The performance of a storage device depends on the electrolyte surface and the electrolyte. Electrolytes can be liquid electrolytes, they can also be solid electrolytes. We have defined what an electrolyte is. We have said ionic conductivity is mutually connected with ion transport under the influence of external electric field. We have seen the three ionic conductors: inorganic solid electrolytes, liquid electrolytes, polymer electrolytes, and the three characteristic modes of ion transport in ionic conductors, namely migration, convection, and diffusion. We have said that in large scale applications, the solid electrolytes are used, and these solid electrolytes, they reduce the corrosion problems in the energy storage devices. There are certain advantages of a liquid electrolyte. In liquid ion conductors, the electrolyte can be added to maintain the desired concentration. The solid electrolytes can be single crystalline, amorphous, and polycrystalline. We have seen one peculiarity of the solid electrolytes, that is, even at room temperature they will have the electronic conductivity, and the electronic conductivity in the case of liquid electrolytes is negligibly small at room temperature. Thank you.